Hello. Today we are doing notes 9.3, solving and evaluating with common bases. So exponential equations is an equation where the variable occurs in the exponent. So for example, 5 to the x equals 25. That is an exponential equation. So there's a property that we're going to use quite a bit today. It's the property of equality for exponential functions. So if b is a positive number other than 1 and you have b to the x equals b to the y, that only happens if and only if x is equal to y. So if 3 to the x equals 3 to the 5, both the bases are the same, so that means the exponents have to be equal. So x equals 5. So our goal is if our bases are the same, right, life is good because then the exponents have to be equal. So here are basically 3 steps we're going to use. Rewrite each side of the equation to have the same base. Then we get to basically drop the bases. And again, the reason we do that is the bases are the same. Using that property of equality, then the exponents have to be equal. And after we do that, we solve for x. So example 1 here. So we have 3 to the x, and we have 1 over 81. We want to rewrite both sides so that they have the same base. Well, 3, there's nothing to do to rewrite 3 really. But 1 over 81 is the same thing as 1 over 3 to the 4th, which is the same as 3 to the negative 4th. So now I have 3 to the x equals 3 to the negative 4th. So that was step 1. Rewrite both sides with a common base. Step 2. Now drop the bases. So what's left is x equals negative 4. Step 3. Solve for x. It's already solved for x. Right? X equals negative 4. So same 3 steps every time. Okay, next example. So we have base 2 and we have base 8. So first step is to rewrite the bases. So 2 to the negative x plus 3 equals 8 is 2 cubed. So there you go. There's step 1. Step 2. All right, drop the bases. So we have negative x plus 3 equals 3. And then step 3, solve for x. So I'm going to distribute the negative 1. So you have negative x minus 3 equals 3. Right? Add 3 to both sides. So x equals negative 6 once I divide by negative 1. So same 3 steps. Step 1, rewrite both bases on each side to be identical. Drop the bases. Step 2. Step 3, solve. Okay, third example, I guess. So we have 4 to the x plus 2 and 2 to the 1. Well, 4, right, for step 1 can be written as 2 squared equals 2 to the 1. So bases are the same. So step 2, I'm going to drop them. So you have 2 times x plus 2 equals 1. Remember, when you have a power, right, I rewrote 2 or 4 as 2 squared, so you have a power to a power, you multiply. So then step 3, right, solve for x, so distribute 2x plus 4 equals 1, and then just solve the multi-step equation. Subtract 4, and then divide by 2. So we get negative 3/2. So again, same 3 steps every time. So first step, right? Step 1, rewrite the bases to be the same. So 7 to the 2x. I can't rewrite 7. 49 is 7 squared. So to the 3x minus 2. So now I have the same bases. Right? just to clean it up, right, this would be 7 to the 2x equals 7 to the 2 times 3x minus 2. Because a power raised to a power, you multiply. So bases are the same. So step 2, drop the bases. And step 3 is now solve. So distribute the 2. So 6x minus 4. Right? Subtract the 6x. So you get negative 4x equals negative 4. Divide by negative 4. So x equals 1. Okay, next example. Okay, now neither one of them is the same or a simplified base. But 81, right? So this is step 1. This would be 3 to the 4th to the x minus 3. 1 over 3 would be 3 to the negative 1 times 5x minus 6. So now, right, if we rewrite this, 3 to the 4 times x minus 3 equals 3 to the negative 1 times 5x minus 6. Now our bases are the same. So we can go to step 2, drop the bases. So 4 times x minus 3 equals negative 1 times 5x minus 6. And then step 3 is now I can solve. So I can distribute. So 4x minus 12, distribute, equals minus 5x plus 6. So we can add 5x to both sides. So we get 9x. And then we could add 12 to both sides. So we get 18. And then we can divide by 9. So x equals 2. And then the last problem in this example, right? Bases are not the same. We have 5 to the x, we have 5, so we need to rewrite square root of 25. Okay, well, that's the same thing as the square root of 5 squared, right? Which is the same thing as the square root of 5 happening twice. So we can rewrite this as 5 to the x equals 5 to the first. The square root of 5, right, is 5 to the 1/2 power. Because you're taking the fifth root, sorry, the square root of 5. So the base is 2 and you're doing it one time, but then you're squaring it. So you have a power to a power. So this is really 5 to the x equals 5 to the 1. 1/2 times 2 is just 2. Right? Sorry, is 1, so this is just 5 to the 1. So 5 to the x equals 5 squared. How did I get 5 squared? Bases are the same, you add your exponents. So now, there's step 1. The bases are the same. Step 2, drop the bases. So we have x equals 2. Step 3, solve. It's already solved. Now, this probably would have been a lot quicker if I just would have realized, oh, the square root of 25 is 5. So it would have been 5 times 5. So 5 to the x equals 5 squared. Right? Would have been a lot quicker if I would have recognized that the square root of 25 is just 5. It would have saved me a lot of algebra work. Wait, so example 2, evaluate, which means you're figuring out what power makes this work. So what power of 9 gives you 27? So that's what they're asking when they mean evaluate. You're figuring out what power makes it work. So what power of 9 gives you 27? Well, it's not a nice whole number, right? Because 9 to the first is 9. 9 squared is 81. So it's not a whole number. It's some type of fraction. So what we're going to do is what we just did like 6 times. We're going to rewrite the same base. So 9 is 3 squared. And 27 is 3 cubed. So this is 3 to the 2x equals 3 to the third. So now the bases are the same. Once our bases are the same, right, we drop the bases. So 2x equals 3, and then we solve. Divide by 2, so we get 3 halves. So 9 to the 3 halves would give you 27. Right, so the power that makes it work is 3 halves. Okay, next one. So we'll set this equal to x. So 7 to what power is going to give you 49 times root 7. Okay, so again, if we're going to solve this, we need to have the same bases. So 7 to the x, right? 49 would be 7 squared. The square root of 7 is same thing as 7 to the 1/2 power. Remember, when you take the square root, that equals the 1/2 power. Because you're taking the square root of 7 one time. So the denominator of the fraction is 2, the numerator is 1. Okay, now, I still don't all have the same base. They're all base 7, but I have 2 base 7s over here. So I'm going to rewrite this. So this would be 7 to the x. Now, bases are the same. You take your 2 and your 1/2 and you add them together. So you get 7 to the 2 and 1/2. You add them, you don't multiply. It's not 2 times 1/2. The bases are the same, you're multiplying. You add your powers. So x equals 2 and 1/2. Because now the bases are the same, we drop the bases. So x is equal to 2 and 1/2. So please be careful with that. Every year, this is where students mess up. They don't add these, they multiply. When your bases are the same and you're multiplying like we are here with the 7s, you add your exponents. 2 plus 1/2 is 2 1/2. It's 2.5. So if you want to, write 2.5. Wait, evaluate. Same idea, right? You're trying to figure out what power of 1/2 is going to give you 32. That's what it means by evaluate. You're figuring out what power makes this work. Again, I don't have the same bases. So the 1/2 I can rewrite as 2 to the negative 1. And 32 is 2 to the 5th. So you have 2 to the negative x equals 2 to the 5th. Right? Bases are the same. So drop the bases. Negative x equals 5. And solve. Divide by negative 1. So x equals negative 5. Okay. So we have a cube root of 1 over 121. So let's see if we can maybe simplify this a little. So 1 over 121 is 1 over 11 squared, right? 11 squared is 121. And this would be 11 to the negative 2 power. Okay, so we know that we're trying to figure out what power of x is going to give us the cube root of 11 to the negative 2. But again, we're not in the same base and we're not in the same form. One's exponential, one's in radical form. So let's change the radical into exponential. So this is still 11 to the x equals. So you're taking the cube root of 11 to the negative 2, you're doing it one time. So 11 to the negative 2 is going to be raised to the 1/3 power. because the cube root is going to be the denominator, the 3, and you're doing it one time, so that's the numerator. So now you have a power raised to a power. So again, the 11x is just coming along for the ride right now. Power to a power, you multiply. So that'd be negative 2/3. So now the bases are the same. Drop the bases. So x equals negative 2/3. And solve for x, but x is already solved for. So x equals negative 2/3. So on all of those, all three examples, all of those problems we just did, no matter what form, if we got into exponential, we wanted the same base on both sides so that when we could drop the bases and solve with the exponents. Whole idea behind all of those problems. When we were in log form, we put it to exponential form, got the same base, and solved. Okay. So we're going to convert from log form to exponential form. So we've kind of been doing this, but now it's going to be just solving a little bit differently. So we're in log form, so it's 9 to the 1/2 power equals x. Well, 9 to the 1/2 power is asking you to take the square root of 9 one time. So that would be 3. So this is a little bit different because we've been looking for the power that works. Now I'm giving you the power, right? I'm giving you the 1/2, right? That's what we've been looking for. So it's a little bit different. We're still using the same concept of having to convert to exponential to help us solve. So this would be 4 to the 3rd power equals 5x minus 1. So then we just solve, right? So 4 to the 3rd power is 64 equals 5x minus 1. So you add 1. 65 equals 5x. So then from there, we just figure out, okay, divide by 5. Right, so 65 divided by 5 gives you 13. And there you go. Okay, so now I see ln. Remember, when you see ln, ln is log base e. Remember, e is equal to 2.718. It's like pi. We're going to use 2.718. E just represents a number, right? Just like pi does. So if you want, you can just put base e here. So e to the 1 is equal to x minus 4. So add 4, and you get x. Now, you could technically take this further, right? And just add the 4 and the e, right? E is 2.718. So you could get 6.718. Technically, I would accept either one of those answers. Again, e is 2.718. So if you add 4 to it, you get 6.718. So just the key, though, is remembering that ln is log base e. Wait, when the same log base is on each side, the two terms are equal. Simply solve. So what do I mean by terms? So the 4x minus 7 and x plus 5 will be our terms. So when the bases are the same, those expressions have to be equal. Because again, equal means both sides are the same. They're identical. So the only difference between the left side and the right side is the 4x minus 7 and x plus 5. Because x and log base 5 and log base 5 are identical. They're the same. So in order for it to be equal, that means that 4x minus 7 has to equal x plus 5. That's the only way that's going to happen. So you got to use a little critical thinking there. So now from here, I just solve, right? Add 7, subtract x. So 3x equals 12, divide, so x is 4. Okay, example 6. So both of them are log base 7. So the only way for the left side to equal the right side is x minus 3 has to equal 5. So add 3, so x equals 8. And then the last example, again, both log base 3. So then that means x over 5 has to equal 10, right? Put that over 1. Again, I get to use that logic because these are the same, so it's like they're not there because they're equal. So again, you can basically kind of ignore them. So then the only thing that would be left is that x over 5 has to equal 10. So cross multiply, x equals 50. So if you look at example 4, all of those were single logs. We changed it to exponential. Right? Every time you've seen single one word of a log, we've gone to exponential every time. Now if you look at example 5 and 6, those have a log on each side. We solved those differently. And that's going to be the case. Sometimes you're going to solve by going exponential, which will be the main case that we usually do. But these two examples, you have the same log base on both sides, so it's like they're basically, we can just like ignore them. That means the terms, the expression that are there have to be equal. And then on the front side, right, all of those we are getting to have the same base. Then we could drop the bases and then solve. Example 2 and 3, those 4 examples, all of them single log. So we put it into exponential form, and that's how we solved. So to finish up the notes, make sure you answer the essential the essential question in your summary, and it should be 3 to 5 sentences long. Once you've done that, then you will be done with your notes. Have a great day.